Greetings, everyone. Today we're going to explore polynomial division using long division. You'll want to have the handout provided for this video, and of course a writing utensil in your notebook. With the handout for this video, if you would fold it like a book, and on the front, please title it Polynomial Division, Long Division. Make sure that that long division stands out in some way or another. Polynomial long division. It's the same as long division as you learned it in elementary school. It can be used to write an improper polynomial as the sum of a polynomial with a remainder. You can also use polynomial division to help you factor completely. Just as you can divide 56 by 7, you can also divide x squared plus 4x minus 32 by x plus 8. Factoring is sticking around, so we're going to use this to help us in that factoring process. Let's take a quick moment and step back in time to go over long division with just numbers before we get into polynomials. To revisit, we want to know what can I multiply 3 by to get my first value of 1? Well, I can't, so then I go to the second option. What can I multiply 3 by to get 17? And I want to get up to 17 without going over. So I would type in a 5. Then I multiply. 5 times 3 gives me the 15. We subtract to end up with a 2, and we bring down what's left over. Now I want to see what do I multiply 3 by to get up to 22 without going over. I would have a 7. 7 times the 3 gets me to that 21. If I subtract, I have 1 left over. I have nothing else to multiply, so that is considered my remainder. So as we write our answer, we have our 57 as our answer, but I have a remainder of 1, and we put it over what we were multiplying by. So I'm missing, out of the 3, I'm missing with 1 left over. So 1/3 becomes my remainder. We're going to use these same steps and ideas, but with polynomials now. Alrighty, let's take what we reviewed with long division and apply it to polynomials. We want to start off by setting up our long division with our divisor on the outside and our dividend underneath. I've got the steps written out here, so let's walk ourselves through. What do I multiply this outer x by to get a 2x squared? Well, I definitely need a 2, and I need an x. 2 times a 1 gets me to 2, and an x times an x gets me to that x squared. So let's multiply it out. 2x times x is 2x squared. 2x times 5 gives me positive 10x. I've multiplied everything, so let's line them up and subtract. 2x squared minus 2x squared gives me 0x squared. And negative 3 minus a 10x gives me a negative 13x. Carry down anything that's remaining. Let's look at our next term. What can I multiply x by to get negative 13x? I need a negative 13. And negative 13 times an x gets me negative 13x. That's your check right there. We know we're on the right track. And a negative 13 times a positive 5 gets me to a value of negative 65. I've multiplied everything, so let's draw a line underneath, subtract, and negative 13 subtract a negative 13, 0. 1 subtract negative 65. Subtracting a negative becomes addition, so we have 66 remaining. Now I can't multiply x by anything to get a 66, so that is considered a remainder. So let's write out our quotient. What you have up top here is your quotient, which is a 2x minus 13. Think of your remainder as extra. If it's extra, we're going to add it on to the end, but we write it as a fraction, so we have the remainder over the divisor of x plus 5. That's how we will always write remainders when doing polynomial long division. Let's take a look at another example. Let's first set up our long division. We want our divisor of 2x minus 1 on the outside. Our dividend, or what we're dividing, goes underneath. First step, what times 2x would get me 2x squared? In this case, the only thing I'm missing is a 1x. X times 2x is 2x squared. Perfect, I'm on the right track. X times negative 1 is negative 1x. Nothing else to multiply, so draw a line underneath and subtract. 2x squared minus 2x squared is 0. 5x minus negative 1x. Subtracting a negative becomes addition, so we have 6x. Bring down what's remaining, and that's a 3. Now I have to look, what times 2x would get me to 6x? The x's are taken care of, so I just need an integer of 3. 3 times 2x is 6x. Perfect, that's what I needed. 3x times negative 1 is negative 3. Let's draw a line underneath, subtract. 6x minus 6x cancels. 3 minus negative 3. Be very careful. I see a lot of people put 0 here, but subtracting a negative becomes addition. So I actually have 6 remaining. Now nothing times 2x would get me to 6. So this becomes my remainder. Our quotient, or our answer, is up here. So our final answer is that x plus 3. We've got a remainder, meaning it's extra, so we're going to add on the extra. 6 over your divisor of 2x minus 1. Let's take a look at example 3. Make note, if a term is missing, we want to write 0 as a placeholder. So right away I notice I've got x to the 4th, x cubed, and then an x. I'm missing an x squared. So I want to fill that in as a placeholder. So let's set up our division. I have a divisor of 3 terms, x squared plus 3x minus 5. And I have a dividend of x to the 4th plus 4x cubed plus 0x squared plus x minus 1. So again, make note of that 0x squared there. Okay, to start off, I want to first see what can I multiply x squared by to get x to the 4th. I would need an x squared. Notice where I'm placing this x squared. I'm putting it over the other squared. Just like when you do with numbers, you've got those placeholders of hundreds, tens, ones. You sort of want to line up your terms the same way. So let's multiply. X squared times x squared is x to the 4th. Perfect, that's what I needed. X squared times 3x gives me 3x cubed. And x squared times negative 5 is negative 5x squared. We've multiplied all 3 terms, so let's subtract. 4x cubed minus 3x cubed is 1x cubed. 0x squared minus or subtract negative 5x squared gives me a positive 5x squared. And bring down any remaining terms. All right, what can I multiply x squared by to get x cubed? In this case, I'm just missing a positive x. X times x squared is x cubed. X times 3x is 3x squared. X times a negative 5 is negative 5x. We've multiplied everything. Let's subtract. 5 minus 3 is 2x squared. 1 minus negative 5 becomes a positive 6x. And I have a negative 1 remaining, so I will just carry that down. All right, I have to keep going on this one. Let's look at the next term. What times x squared would get me to 2x squared? In this case, I just need a 2. 2 times x squared is 2x squared. 2 times 3x is 6x. And 2 times negative 5 is negative 10. Let's draw a line underneath and subtract. Perfect, my 2x squared cancels. Oops, that should be a subtraction symbol there. 6x minus 6x also becomes 0. And negative 1 subtract negative 10. So negative 1 plus 10 gives me a remainder of 9. So let's take a look at our quotient up top. Our solution to this division problem is x squared plus x plus 2. Tack on or add on the remainder of 9 over the divisor of x squared plus 3x minus 5. Take a look at one more example. Let's set it up first with our divisor of x minus 3 and our dividend of x cubed plus x squared minus 8x minus 12. Not missing any terms here, everything's there. So let's start off. I want to find, what do I multiply x by to get x cubed? And that would be an x squared. X squared times x is x cubed. X squared times negative 3 is a negative 3x squared. Multiplied everything. So let's subtract. 1 subtract negative 3 becomes a positive 4x squared. Bring down what's remaining. All right, let's try our next term. What can I multiply x by to get a 4x squared? Well, I definitely need a 4 and I need 1x. So 4x times x is 4x squared. Perfect, that's what I needed. You have these sort of mental checks every time you do that. You have to end up with the same thing. A 4x times a negative 3 would give me a negative 12x. I've multiplied everything. So let's subtract. Negative 8x subtract negative 12x would give me a negative 8 plus a 12. So be very careful with your signs here. Even though they're easy calculations, it's easy to make a mistake with those signs. We actually end up with a 4x here. Negative 8 plus 12. Carry down what's remaining. We've got to go through this one more time. What times x would get me to 4x? A positive 4. 4 times x is 4x. 4 times negative 3 is negative 12. We've multiplied everything, so let's subtract. 4x minus 4x is 0. Negative 12, subtract negative 12. So negative 12 plus 12 is 0. Okay, well we have a remainder of 0 here. It's nice and convenient. So first of all, let's start off by writing our quotient of x squared plus 4x plus 4. So what that means is when you have a remainder of 0, it means that x minus 3 is a factor of that polynomial. Meaning x minus 3, if I have that as a factor, I could factor it out of that original polynomial. So we are dividing, but essentially we just factored out an x minus 3 and ended up with an x squared plus 4x plus 4. So that's the big connection here, is essentially we're trying to see what can I factor out, or is it a factor of the polynomial? Factoring's not going away, so we're going to keep working on this. All right, make sure you've kept up on everything from the last unit into this unit. I'm going to do a check for these notes tomorrow, and we will continue with some more practice on long division tomorrow as well. We'll see you next time.